Hello, this is Mrs. Snook with Section 1.2 Functions. Our objectives today are to decide if a relation between two variables represents a function and to use function notation and then evaluate functions. So let's go ahead and get started. First up, I'm going to give you two relations and we're going to see if they're functions or not. So I have the points 2, 2, 2, 10, 3, 8, 4, 5, 5, 1. Now the key for a function is that each distinct input, or x, has to go to one and only one distinct output. So when I look at my x's, check this out. Right here I have a 2, right here I have another 2. So that's the same x input 2. But the outputs are different. I have a 2 on my first point and a 10 on my second one. So that is not a function. Because remember, each x maps to one y. Now look at the second one. We have -2, 3, -1, 0, 0, -1, 1, 1, 2, 3. Now check the x-coordinates. Do any of them repeat? They do not. So this one is a function. Another way to look at it is to draw a diagram. So I'm going to do the diagrams for both of these. So right here, on this side, I'm going to do the first one. Then over here, I'll do the second one. Because if you think graphically, if you think in pictures, it might be easier to do it like this. So I'm going to put all the x's in one circle and all the y's in another. So 2, 2, 2, 10, 3, 8, 4, 5, 5, 1. Now I'm going to draw from each x its y. So 2 goes to 2, 2 also goes to 10, and then 3 goes to 8, 4 goes to 5, 5 goes to 1. So check it out. Right here, this 2 goes to both the 2 and a 10. Now I want to point something out. I wrote down the 2 that's x twice. You don't need to do that. So I'm going to take this out of my domain because I only have to put in x once. Now let's take a look at our second function. This one is my second set of points, and I'm going to put an x in. Let's switch over to a pen. So I'm going to have x and then y, and then each one has its x points and y points. So I have a -2, 3, and then I have a -1, 0, 0, -1, 1, 1, and 2, 3. Now let's sketch the mappings. -2 goes to +3, -1 goes to 0, 0 goes to -1, 1 goes to 1, 2 goes to 3. Do you notice how none of those are overlapping? So from a picture standpoint, this one is not a function. Because of that, and this one over here is a function. All right, now we're going to test for functions algebraically. So I'm not going to use a graph and I'm not going to use a picture. I'm going to look just at the equation. And the first thing I want to do is rearrange my equation so that I have a y equals. So what I have to do for this one is I have to subtract x squared from both sides. So I get a y equals 1 minus x squared. That's this function rewritten. Now I have to decide, is this a function of x? So for x to have one and only one unique output, there's two things you have to look out for. The first thing is you cannot take a square root of a negative number. So now, in fact, I want to rephrase that. Do not take an even root of a negative number. So now take a look at our 1 minus x squared. Do I have a square root of an even number going on here? The answer is no, I don't. So this one is a function. All right, let's take a look at another one. This time it's going to be negative x plus y squared equals 1. I'm going to add x to both sides. That's going to give me a y squared equals x plus 1. Now to solve for y, I have to take a square root of both sides. So I need to square root this, and I need to square root that. Now here's a rule of thumb. When you put in the square root, you then have to do plus or minus. So when you write the square root, so if you're writing a square root while you're solving a problem, when you get down to your answer, you have to take both the plus and the minus. So check this out. Since I took both plus and minus, okay, since I did that, that means that I have one x, the same x, but it goes to two different y's. So this one is not a function. And the reason it's not a function is this plus or minus right there. If I'd been able to take just one of those, then when I square root my y, I get just one answer. Oh, and look at this. I think I have a little notation mistake there. That's a y equals. So do you see how with a y equals plus or minus x plus 1, whatever I put in for x, I'm going to get two numbers out. So not a function. All right, now we're going to evaluate a function. I want you to notice the notation here. I have g parentheses x. That's pronounced g of x. Do not multiply. Many times when students see those parentheses, they think multiply, because most times it does mean multiply. So if I did like a 2 parentheses 4, you would say 8. But in function notation, where you have a letter here, it's g of x, so do not multiply. That's the difference. Instead, what you do is whatever is put into the x, so whatever is written right here, you plug that into the function. So I would plug whatever's into there and into there. So I'll show you what I mean. First, we have g of 2. So that means wherever x was, you're going to put in a 2. So this is going to equal negative 2 squared plus 4 times 2 plus 1. Everywhere there was an x, I put in a 2. And then I'm just going to evaluate that. I'm going to get a negative 4 plus 8 is 4 plus 1, 5. Now we're going to do g of t. So basically we're going to change our variable. Anywhere there's an x, I put in t. So I get negative t squared plus 4t plus 1. Last one is g of g plus 2. So now wherever there was an x, I put in g plus 2. So negative g plus 2 squared plus 4 times g plus 2 plus 1. Now this one, I can simplify this a bit more. I can go ahead and square the g plus 2. I can distribute the 4. So I'm going to get a negative g squared plus 4g plus 4. And then I'm going to distribute this 4, so I get a 4g plus 8 plus 1. Don't forget to distribute this negative. That's going to give me a negative g squared minus 4g minus 4 plus 4g plus 8 plus 1. Now I'm just combining like terms. I get a negative g squared. My negative 4g and plus 4g, those cancel each other out. I have a negative 4 plus 8 plus 1 is 5. So here is my g of g plus 2. All right, the next thing or last thing I'm going to do is I'm going to find the domain of a function. Two things to watch out for. The first is you cannot divide by 0. So for domain, these are the two rules I use. Number 1, I cannot divide by 0. And then number 2, you cannot take an even root of a negative number. So no divide by 0 and no even root of a negative number. So what that means is when I'm looking at a function, I'm looking for places where that can happen. So here I have k of x is 4x minus 3. I don't see any place where I'm dividing by my variable. So the first thing I'm looking for, dividing by 0, that's not going to happen. I don't have to worry about that. But my 4x minus 3, that is underneath a square root. That's an even root. I cannot allow 4x minus 3 to go negative. So I'm going to say 4x minus 3 has to be greater than or equal to 0. It's okay to take a square root of a 0. It is not okay to square root a negative. So therefore my 4x minus 3 has to be greater than or equal to 0. So I'm applying rule number 2. I'm going to solve this inequality. I'm going to add 3 to both sides. I get 4x greater than or equal to 3, and then divide both sides by 4, and I get x greater than or equal to 3 over 4. That's the domain of this function. X is allowed to be greater than or equal to 3/4. You can write it that way, or if you're going to use set notation, you're going to say x negative infinity. Nope. It's got to be bigger than 3/4. So 3/4. I use the square bracket to say that the 3/4 is included, and it can go all the way to positive infinity, and a round bracket. I would like you to get comfortable with both notations, so you will see me writing it both ways, or I might write it one way and not the other way, just so you can get used to seeing it both ways. All right, that is it for today's video. Thank you for watching and have a fantastic day.